All right, morning, everybody. Reminder to sign in on the agenda. And if you have any additional items you'd like to add, please add them at the end. We'll get started in 1 minute. All right, should we kick things off? First thing is introductions. Do we have any new faces today? I don't know, Laksha, I don't know if I've seen one of these before.
Hey everyone. I've been here like last 2 meetings are there. Last meeting I wasn't there. Before that,
Got it. Sorry, I think I missed the last one. All right. Great. Next thing is release planning and updates.
On the lifecycle side, we're still working through the next platform and ZOPAC APIs. So we will release when we're finished.
On the bad team side, I think I'll probably be putting in a RFC for creating a test utils repository. So now that we'll be owning utilities as build packs, you'll probably need a way to do integration testing on them. So that library will serve that purpose as like a companion library to libCNB. So probably be putting it out before our sub-team meeting tomorrow.
Any updates from the platform side? I guess I don't see Javier here. Seems like no. So we'll move on to, sorry, any other sub-team updates, distribution, learning?
Nope.
Cool.
On the learning side, we did discuss the possibility of adding friendly badges for contributors, especially as a way to encourage or like have contributors or even mentees in like programs like LFX or GSOC being able to say that, hey, we did the mentorship with build packs or we contributed to build packs. So probably that.
Awesome. I think I saw some discussion of that in Slack. All right, we'll move on to the first agenda item. SIFT is a moving target.
I put this one. So I know everyone's favorite topic is SBOM compatibility. I feel like one of the things, that we've been running into lately, that I'm not sure we've thought there was a group when we were planning out these formats, is sort of how to deal with the fact that these formats themselves are young and evolving through multiple major versions. Like in our build pack spec, we've said like these media types are going to describe like very specifically how you write a format that's for SIFT or a format that's for Cyclone DX. But when those formats themselves are major versions, I was wondering, like, have we thought about, like, do we need a way to express those different major versions in the file names? There can be a compatibility window where you support both of them. Like, is this something anyone else has run into?
So I can't say much about SIFT, but SPDX and Cyclone DX have a strict backwards compatibility a guarantee around the major versions. And they also put the version numbers in the document itself. So if Cyclone DX pumps its version to V2, let's say in the future, it will be in the BOM version field in the output bill of materials. So that will be for breaking changes. We'll know that, okay, this BOM format is inherently different and incompatible with 1.x. Any Cyclone DX 1.x BOMs are like, they will always be backwards compatible. So if you use one of their official libraries to decode or encode things, you will always be able to decode a future version of the BOM with a past version, but you'll be missing fields. You will still be able to like decode it and encode it back. There might be loss of information if you're using an older version though.
So I feel like the problem might be more exaggerated in SIFT, which is slightly younger, but like even taking the Cyclone DX example, like, you know, when you move to 2x, there might be a breaking change, and that schema version is in the BOM, so you can look it up and see that there's a breaking change. I think what I'm curious about is like, we've been pretty prescriptive about how you specify the file name for something, right? So let's say I want to add support as a build pack author for the new V2 Cyclone DX BOM, but I know that there are integrations that people are depending on that are built around my build pack producing the 1x format. I was wondering if we need a way to sort of capture those version numbers in the file name so we can produce both to have a window of overlap. Because I think right now there's no way to upgrade between breaking formats of a BOM while providing backwards compatibility as a build pack author.
Interesting. That is certainly true. So the idea would be that you want to output both for a duration of time.
Yeah.
I mean, I know that Cyclone DX is not planning any major versions, but the SPDX major version is coming. And that will be a breaking change probably.
Yeah. I was just thinking about this. This is like the kind of thing that like we might want to get on top of before some of these tools have major breaking versions, because
for SIFT at least, there's no guarantee that the version is not something that the version is a consequence of the implementation. It's not something that's spec'd out.
yeah, it seems like SIFT is kind of the Wild West, where it's like
Yeah. It's because the SIFT model is literally their internal like BOM model serialized onto a file format, and they provide no guarantees towards that being stable. Although they like traditionally they do the same thing. If there's like fields that they've entirely removed, they would do a major version bump. Or if there are new fields that they've added, they're supposed to do a minor version bump. Sometimes that just doesn't happen. The other two formats are pretty standard.
we don't have to talk about this too much more. I just wanted to throw this out as something that was on my mind and get the feeling of the group, because we've gone, I feel like, tried very hard to make build packs very stable such that you can, you know, depend on their output and we can still upgrade things and stuff like that. But, you know, now that we've added sort of encouraging people, I think, first of all, we haven't thought through what will happen when there's like a breaking change in SPDX. Like, we should figure that out early. But then I think there's another question, which is like, by adding sort of the SIFT media type, we're sort of encouraging people to create this format, but that is inherently unstable, and there isn't as much we can do with our APIs to provide guarantees around that.
So the reason why we introduced SIFT in the first place was because of its usage with Gripe. As of the next month, Gripe will be supporting both Cyclone DX and SPDX as input formats. So the need for outputting SIFT bombs would be lesser and lesser, hopefully. And as of last week, we also introduced a way to encode additional properties on both, like that are SIFT specific onto both Cyclone DX and SPDX. So I think the SIFT folks at least want to use standard formats. The SIFT JSON was like, I don't want to speak for them, but it was like an intermediate format that they just store everything in and they have complete control over. But I think they found good alternatives for the other standard formats. Hopefully we'll see better support for both SPDX and Cyclone DX and Gripe really soon.
Going back to that more general question about like, how do we manage major version changes in, the SBOM files? I wonder if the problem isn't, like build packs needs to come up with a way to support multiple major versions of different formats. But if it's just a problem of we've added support for providing multiple SBOM files, but you can only have one SBOM file of a given type for, in some cases, like layers, right? Is the problem that maybe it's not that we need to introduce a, or layer name dot, spdx.json.2 or something, but really that we need to introduce like, the ability to use a layer prefix or something like that, in addition to just the layer name, or a layer directory that is named the way a file would and then contains, multiple SBOMs, because then you could put multiple SIFT SBOM versions of the same stuff, multiple Cyclone DX SBOM versions, right? They could share the file extension, but and that would be a change that, in the end puts more of the onus to manage that on the build pack authors, but that's kind of the direction we were going with this whole thing, anyways, is like, we're not going to try to merge SBOM. It's, build pack, we want to give build packs kind of a maximum API they could have to produce these things in a way that we can, deliver into something that you can attest to.
I think I agree with that. I'm not really suggesting that we be prescriptive here, more that we've been prescriptive to a point where there isn't a workaround for it.
I think the reason why I didn't initially add the version numbers in the file name was because you could, like, each of these formats had the version number inside the file itself, so you could figure out what the version was. But we never considered the case where a build pack would want to output both V2 and V3, for example. But I like Steven's solution of just giving the build packs the ability to output multiple bombs, like of the same format. That also gets rid of like if for whatever reason you want to produce multiple SBOMs of the same type, you can do that.
All right, I think we can move on to the next one, Stephen.
Sounds good. Maybe someone will open an RFC. Next one is cosine RFC from Sam.
Let me share my screen. So since I last presented this, I've made a few changes. One, I've completely removed the dependency on the existing build pack phases. We've introduced a new phase signer which runs after export. It can be a part of the lifecycle repository, can live somewhere else, like pack or whatever. It's just a Go binary that, or just any binary really, that takes in the following inputs. The report.toml produced by the exporter when it's run in OCR registry mode, and a cosine config. There were a few comments around the cosine config containing the password and the private key inline. I removed those. and set them to be paths to files, which can be mounted like as volumes from secrets or whatever. I've also made the SBOM attachment option more generic. So now you can choose whether you want to output none or the SBOM as an attestation or as an attachment, with the default being that it will be outputted as an attestation. And the idea would be that the signer would read in the output from report toml, which contains the list of tags that the lifecycle published, the manifest digest, and the manifest size. The signer will verify that it has, like, based on the cosine config and the output tags in report.toml, it will try to construct a matrix of signatures and attestations it needs to put out. It will then reuse like registry credentials the same way Lifecycle does, and export out the launch bill of materials from the output image in the registry as an attachment or an attestation. It will read the final SBOM from the output image, since that's the only thing we currently spec out in the platform API. The internal sort of places where the lifecycle moves it around is not really something that the platform should concern itself with. So that's why I just wanted to keep it to the output image itself. And yeah, it just generates signatures for everything as defined by the config. Now you can use this binary potentially as a library or as a binary itself. Works pretty much the same way as like how Pat currently just calls out binaries from Lifecycle. It can just call out CNB signer. And it will have to construct this cosine. The platform will have to construct this cosine config. But it precludes it from being dependent on the daemon, because it's an optional step. The platform can choose whether or not to invoke it. And I have not yet put where this should go, but if there's some strong consensus that it should not be in the lifecycle repository and it should be something separate, happy with that. But think like lifecycle has a few utilities that would make dealing with multiple platform APIs easier. The other thing that this raises is like, where does this go in the spec, or does it go in the spec? And if it does not go in the spec, how do platforms with different platform APIs try to interact with this? Those are open questions. But I think this is as generic as it will get, and as decoupled from the current lifecycle phases as I could think of making it.
What makes this feel different from other lifecycle phases to me? It's like, what makes the lifecycle hard but necessary in a lot of ways is that it's mediating between these two APIs. So it's like, as a platform using any of these versions, I can have a build pack using any of these versions. This doesn't have to fill, as far as I'm understanding, that roles a compatibility layer. Is purely just a utility for platforms to use. So I don't think it needs to be managed as carefully. I feel like platforms can just pull it in and update as at will, which is different from the lifecycle where you always want to be getting the new one so that you can use new build packs, because you need that compatibility layer to be up to date to keep everything working, right? So I wonder if that means it should have a different model of distribution, whereas it makes a lot of sense to put the lifecycle on the lifecycle image or on a builder image, because you have build packs there and you want to make sure that the lifecycle is new enough to run the build packs that are there. Whereas I feel like the platform could be responsible for pulling in the version of the signer that's right for it, like the I feel like that one makes sense to be totally within the platform's control. There's no tension between like, as a builder author, I want this version of the lifecycle. As a platform, I want this. Like, luckily, that whole problem just doesn't exist. Like the platform can just pick whatever version it thinks is the right one.
That's true. It's completely decoupled from the buildback API, just dependent on the platform API. What would have been nice if we could ship it with the lifecycle image. Now we could have bundled it like with builders, or like pack create builder. You don't now have to worry about adding the sign binary in a trusted fashion. And ideally, this sign binary should also be run in like that restrictive mode that we run, like analyze, restore, and export in.
It's dependent on report toml, though, right? So it wouldn't work with any. It's kind of like, or is it that different from exporter?
It depends on report toml, but that's just the consequence of the platform API. Like it's entirely dependent on platform API, but it's independent of the buildback API, which is what the lifecycle currently mediates between. This is just purely platform API, which is the first, I think. We've never had to touch the platform API as a standalone thing. We've always sort of used lifecycle to tie the buildback API to the platform API.
Yeah, even the exporter, Stephen, like looks at buildback output and then makes decisions about what to do. Like you can imagine a world where we clean that up such that the builder outputs changes the format and the exporter doesn't have to care. But at the end of the day, I think it doesn't
that's
matter
right.
as much to people.
We've talked about making the exporter more decoupled from the buildback API, but it's not there yet.
We haven't done it yet.
Once publish RFC does a bit of that, so I think that would be a nice segue when we later talk about it. But as this RFC is right now, any thoughts on whether this should be a new repository or lifecycle, or like how to bundle it? How will we introduce it in the platform API, if we want to?
From Pack's perspective or from platform perspective, I think if it's an optional thing that, hypothetically doesn't need to exist for other distributors of a lifecycle, right? Because again, that is a possibility. Then I would say that it probably shouldn't be included in the lifecycle image and be treated as a standalone utility that Pack could then fetch from wherever it may live, right? So although there's some benefits in putting it in a builder or putting in the same lifecycle image, I think there's more complexities in verifying that exists and, kind of specking out how that should look like on the image to make sure that, platforms like Pack know that it is within that location, as opposed to then always fetching it from somewhere else if need be. I think that's a better approach.
For Pack, would it make more sense as a Go package that you could import with the API so you don't have to grab the platform specific binary or stream something into the container? Would it make sense if Pack could just import this and then do the signing directly?
I think
Pack does with Rebaser, right?
Yeah,
I was going to say, I think we've talked about this where I think Pack needs both potentially. It needs, definitely the Go library aspect of it would speed up and make a lot of sense. But in some cases, I know Pack is used as a development tool for a lot of these components. So being able to specify, hey, I want to use this cosigner that happens to be on this other image that I'm working on, right? They want a way to kind of use that in the flow. I think we need to allow a flag as well. But that's implementation detail at that point, right?
I think this would be in a very similar place as Rebase, I think.
Yeah.
Where it can be imported both as a Go library and like a standalone binary. The standalone binary would be useful for platforms like Tecton, who just want to like run this. And for back, I guess you can just import it as a library.
I think as far as it being in another repo, I initially leaned towards it being in like another repo and just referencing the things it needs from like lifecycle. But I can see like thinking through like how it's going to do the registry authentication. If it's going to like bind itself to to using the existing lifecycle like CNB registry auth, then like, maybe it could belong in the lifecycle. But I guess I don't have a strong opinion on it. But I think I still lean towards separate. But
are those auth packages exported or are they internal?
I'm not sure. I think they're internal, or at least some
Auth
of
is
it is.
exported. Auth is definitely exported because Pack uses it.
Then I think there's like very little utility in keeping it in the lifecycle repository if we can just import the code.
Yeah, given that it's a different output, right, of the thing that it's producing, and then that way it could also have more self-autonomy for any sort of updates that it needs to produce and not have to be tied to a very specific lifecycle release. It might be smarter to go with a separate repo.
I agree with that. Also, the lifecycle does this thing where like one version of it can be every API, but you don't need to do
Yeah.
that for this. We could like do a branching strategy. I also
Yeah.
don't know if we even want to put this in the platform API. Like,
I
It
think
should be like an extension, like preparer is kind of what
Yeah.
I would see.
or like, is this a situation where we want to get into not specking things we don't want to spec? Like if it just had really well documented utilities for signing and we tell platforms how to pull them in and use them.
it's just the dependence on the report toml that's important. Just why we have any dependency on the platform API whatsoever.
What does
There's
it need from report toml? Like, is that easier to spec out as different args or a convenience of reading a report toml so that platforms could be a little more specific and push that information in different ways?
It's just the trust aspect of it. Once you've pushed the image out to the registry, you need a trusted way to know the exact digest of the image that was published. And the input, hopefully, since it's coming, like the report.toml would have been hopefully produced by a trusted export step and carried over to the sign step. So it's just maintaining a
Right.
trust boundary. We're doing things.
If you're using this as a library, you would like the platform would read in report toml potentially and not have to pass it a report toml file is kind of what I'm getting at. Like if we have sort of the either or option of passing a file for like Tecton sort of implementations and then platforms can pass in the different arguments, then that feels pretty good.
I feel like passing in a report toml versus reading a report toml and passing in the digest is not materially different trust stamps. Like the fact that it's got the same file name and schema doesn't mean it was really produced by the exporter. And if it keeps the, APIs easier just to pass in that one piece of information, I say we do that instead.
It's also about like making platforms like Tecton being able to implement this easily. So like we will already have the report toml there out and exported. So we just make it really simple for us to pass that information along.
Just want to interrupt for a second and say we are a little past halftime and we have 5 things on the agenda. Can we kind of move this into GitHub or Slack or pick it up during office hours? Awesome. I think the next thing we have on the agenda is a demo from Natalie.
Hi. Okay. Let me share my screen. This one. Okay, you can see GoLand, right? Now Chrome. Okay. All right. So I think most of us are familiar with the support Docker files RFC from Stephen. And what I will show is the product of effort from myself, Jesse, Ozzy, and Charles, who's not here, to implement at a high level what's described in the RFC. So what I'm showing right now is a draft PR to the life cycle. And this branch is capable of running a build that uses extensions to modify the build image and the run image, and then get an app at the end of all of that. So we made a test script to do that. So I'll just walk you through the script so you know what you will see. Right now, we're assuming that we're using a registry as our mechanism for interacting with images. We build the lifecycle of this branch. Then we build a base image for build that will extend later. We're building a minimal image where the extender will run. And then we're preparing fixtures. So the first thing that we do is we run detect. And obviously we don't have a pack that supports extensions yet. So we're just using Docker as our very simple platform. And I will show the fixtures over here. So we're just using kind of like mimicking what the container will look like with a CNB directory that has build packs and extensions. There's an extension that will install curl. That's here. Here's where it creates the Docker file that does apt-get and install. We also have an extension that really does nothing, but it sort of demonstrates the concept of a pre-populated output directory where the extension author has already created the Docker file. It's just hello world. And then we have a build pack that uses curl. That's this one, just to print the version and demonstrate, hey, I have curl, right? So when we run detect, we're going to mount in that CNB build pack, CNB extensions directory. We'll also mount in a layers directory that has an order toml. And here's where we're saying, okay, run detect on these build packs and extensions. And then we invoke the detector. And at this point, it's actually before we jump into the demo, I'll just walk through the other phases. So the next thing we do after we run detect, we get as an output the group and the plan. We are going to provide that to the builder. But we're going to tell the builder only run build for extensions. So this is the point where we generate the Docker files that will be applied. Then we extend the build image and in the same container, run the builder again, but this time running bin build on build packs so they can execute in the context of the extended image. That's what this step is. So we actually, the binary we're invoking is the extender, but then the extender afterward is calling the builder. I can show that. Then we extend the run image, which is just simply basically replacing or placing into the registry a new image that we'll provide to the exporter later. So you can see this is the extended image, and we provide that as an argument to the exporter when we run it. And then finally, we validate that our app run image is extended. So I think to show, I guess to prove that this works, what I'm going to do first is comment out this samples curl extension. So when we run the build, the build pack that needs curl should not find it. Let me run that. I should say up front, we didn't do caching yet, so be prepared to watch some slowness. Okay, so here is our samples curl build pack complaining that it couldn't find curl in the build image. And then when I put it back, we'll get farther. Here it's installing curl. All right, so now I think we just saw the build happen. It was really fast, but that completed successfully. Now we're extending the run image. Again, it's slow. So it's all happening fresh. Now we're exporting, and here we can see we were able to curl Google from the app image. So that's where we are. If anyone's interested, there's lots of comments and kind of notes about all the uncertainties and things still to be done. But
This is awesome. I had one question. I saw earlier in the shell script you had where you were running the different lifecycle phases that were invoking the builder phase twice, as opposed to having a different phase. Is there, like, the phases aren't separate binaries, they're all subcommands of the same binary. Is there a reason to reuse the same subcommand? Like, if we just need to reuse the code that runs build packs or something like that, is there, I don't know, would it make sense to make a separate subcommand / phase?
Just for running build on extensions?
Yeah.
We could. I think the way it's done right now is just the most expedient for getting something to work. But I don't see why we couldn't do that.
Got it. That wasn't like an intentional design decision because the APIs are similar. It was just fastest way to get the demo out. Yeah, got it. That makes sense.
There was a thread yesterday in the implementation channel around user changes, and like, currently is the final user in this run image set to root, or does the lifecycle handle and reset it back to the CNB user?
Right now, the lifecycle doesn't do anything. We just take whatever the last Docker file, whatever the Docker files did, we just take it that way. But if we wanted to, we could do some modifications.
Yeah, which probably means that example is root, right, Natalie? Probably. Like,
we should probably write this out in the RFC in general, because that's going to be a very common use case where people switch to root and then they want to switch back to the default user. I think there were just some concerns on this would be a very common pattern. If we could improve it, that'd be great.
Is there any difficulty switching back to the default user? I think the environment variables should still be there, right?
I thought the same. Apparently, the environment variables are only required for the build image, not for the run image. The run image, you can there's nowhere in the spec that states that you're required to have those in the run image.
Interesting.
So that's what I assumed and told the person, and then they were like, nope, this is just required for the build image. And so we should probably make that mandatory for the run image so the lifecycle can switch it back.
Yeah,
That surprises me. I would have, if you asked me to say, I would have said it was required for both.
I think I remember not intentionally saying, "Oh, this isn't necessary here because it's the run image." It's not putting that somewhere. That's probably my fault.
Does it need to be required? Or like if you did a scratch image, could you create your own users like for your own platform or something like that? I mean, obviously you can do that anyway, but
even then you can still set a non-root user, right, for a scratch image.
yeah, I just meant, do you have to use this? Like, do we need to be passing along the CNB user ID and use in group ID, or do we need to just be able to facilitate switching back if you extend the the image that you that would have been the run image to begin with?
Yeah, I guess to that, my question is it the responsibility of the extension to set the final user, or should the lifecycle have the opinion that it'll always switch back so that the extender doesn't have to worry about that? I would rather the latter, right? Like if I'm writing an extension that just wants to install a package, I don't want to have to remember like, hey, I have to switch back to this other thing.
Maybe there's like a middle ground where we could pass the user ID and group ID as build arcs instead of relying on the environment variables. That way they could be the values, the actual values of user right before whatever Docker file executes. So you can reliably switch back to something that another build peg didn't change to something else. If that makes sense. That might be safer than relying on the environment variables, and at least it would give you a really consistent way of switching back and forth. I don't know if I would go as far as to have it switch back automatically, because otherwise, like the point of the Docker file integration is you can do whatever you want. You can switch to a entirely different base image, right, using a multi-stage Docker file. And so it's possible that I see some smiles about that one, but it's possible that attempting to switch back would switch back to something that's not the same user, right, with different permissions in the file system. That could be a security issue. I'm not sure if I would try to interfere too much with what those Docker files are doing.
I think it'd be I think it'd be nice if there was a way as an extension author that you could have a user directive that would set it back to what it was before the thing began, if you see what I mean. Because as an extension author, if I'm writing something that just needs to run root to install a runtime, I don't really care what the user ID was before I did that, but I'd like it to go back to being that after I'm done. Now, either that's something I cooperate in by having a user statement that references build args or references environment variables that are available to me, or it's something that's an option that's automatic. But I don't think it's safe to rely on everybody to have to figure out what the original intention of the run image was regarding user ID, run ID. And the other part that's coming up with that is there was a discussion over on the spec channel about the fact that the run image may have a different UID, GID at runtime than the build image will, because that way, you've got a user ID that doesn't have permission to go right to certain areas, whereas the build image needed that.
Yeah. But, sorry, go ahead.
I was just going to throw my case one more time. I think as somebody trying to use the build packs, even just very recently, and thinking about this, like, again, for the use case that I have, where again, I just want to install something, the less I have to know about the internals of what's happening behind the scenes, the better. So if I just want to switch over to root, execute my thing, and fire and forget, that would be ideal when we talk about those escape hatch type scenarios. I shouldn't have to know what's happening, or that I just affected the runtime user aspect of things. So I propose, would it be difficult to, when you specify the order, whether it's an extension somewhere, where there's a config that the default is that it automatically switches back, but then there's some sort of configuration element where you could make it more or less sticky.
I don't.
Sorry.
I don't know if I agree that the obvious thing to do is to switch the user to root and then switch it back to what it was before. Because if you're using Docker files, you're used to extending a base image that you have a deep enough understanding of that you can modify, right? Metadata and contents. People don't write Docker files with variable base images, right? And like we're doing with taking the build arg as the name of the entire image, right? And then expect to use that with, expect to run commands on generic images. That's like it's not a common pattern, right? People use RPMs to install packages or use deb to install packages, right? And so generally, if you're starting from a base image where the user isn't root, right? You would expect to change the user to root and then, have to change it back, if that's what your base image was. If you're starting from a base image that is root, obviously you'd expect not to need to do that. And so it seems kind of different from how Docker files normally work, right? To change the user to one thing and then change it back again kind of at the end.
But as an app developer, like I typically just do the thing that I want to do, right? In most cases, as an app developer, I will be running this container as root, right? Not the best, practice, but it is the most common practice to not have to worry about those sort of things.
I feel like there's a subset of things that are kind of, we add requirements that are different than what you can do in a Dockerfile case, even with this new escape hatch, right? Like the spec still says that the group of the default user in the run image has to match the group at build time. So to the extent that our spec says this must be true, I feel like we should either make it true or fail if it's not. But I think that's a small set of things.
I think my suggestion was we ensure that the run image also has those environment variables set, and the lifecycle just uses that to switch things back to the final user. If you want to modify the final user that's switched to, you can just modify those environment variables.
I worry
like
about
the idea of doing like build args if we want to provide it to the Docker file. I feel like when it comes to setting things back, the environment variable isn't as important as like the actual GID of the starting user, right?
But the use case, like the main reason why we started out with this thing in the first place was people wanted to do things as root. The first thing they're going to do when they use Docker files is use the instruction user root, do stuff, and then change it back. Like that's imagining the most common use case.
But how do you know what you're going to switch it back to?
No, I'm saying that's the most common use case, so we should fix that.
Indeed, but usually if you're doing this in a multi-stage build, you've got full visibility of the Docker files that came before you. In this case, if you're writing an extension, you don't. You're one of many extensions. You don't know what came before you. You don't even know which run image you're running against or what user ID that may have left you to run as. So if you don't know what user ID you came in on, then how are you supposed to put it back?
we can provide that through build arg, right? Like,
yeah,
I think what Sam is saying is that like that pattern, like we can make it so that that's reliable, right? But having to repeat user root and user something else over and over again, because there's a use case here that's running things as root that is very common, because otherwise you'd probably use a build pack for it because it's faster, right? Should we optimize for that? Is that like did I capture it? Yep. I still worry that like the multi-stage example, right? Say you have the new base image you're pulling from uses different user IDs, right, from the original base image, and the user that was CNB user ID on the original image is now a user that can write to some privileged location that you definitely don't want written to during execution, right? just our, or say CNB, I think we force CNB user ID to be numeric, right? We don't let them be names that might not exist.
It's the UID, GID, always.
Yeah. It's a little bit better, but I still think there's a risk that we're doing something magical, if that makes sense, that the person who authors the extension may not understand is going to happen, right? And that because this is very much an escape hatch, do whatever you want. Like, here's your base image, we're hands off now, it's no longer rebasable, up to you, right? I feel like it feels a little risky to me to start going back the other direction and saying, oh, we're going to clean up the interface. So it's a nice way to write a Docker file when the purpose of this is kind of like, nope, you're on your own. You got your base image. You're going to do whatever you want, right? I think because we've opened that amount of flexibility up, trying to go back and then paper it over with like, oh, we're going to switch the user IDs back afterwards, and we'll do all these nice things for you, right? I think it has to be possible to switch back to the same user ID that you started with through something like build-args, but I hesitate to suggest that we should do it automatically for the user without, at least without really making sure that's the behavior they want.
Yeah, I agree with Stephen here. I think we should do as little magic as possible in the extensions. We're already giving you a Docker file. You can do all sorts of things, and I feel like it kind of goes into verifying what you've done. Like maybe we can add some stuff where like when you run extender, you can get some warnings if the user is not the same user than it was before or something like that, if you really want that to be like an output or something. But I feel like blocking it or doing it automatically seems like a step too far given the power we're giving them here. And our patterns and documentation can have the simple, like, maybe you scaffold one and then it just has the, user root and then user args at the end. Like, seems reasonable.
I do think that to the extent we have a must in the spec, though, we should fail if at the end of extensions, those requirements aren't met. And there aren't many of those. I think the GID being the same on build and runtime is one of them.
So it's not a must.
It's not a must, it's a should.
Yeah.
I thought we made that one a must.
No, we said that it
Okay, then don't enforce it. I don't want to enforce anything that's not a must, but I think where we have a must, we should enforce it so that we can, stick to that. I think when we have a must, we're allowed to assume that it's true all the time. So we should enforce anything that we say must for. But other than that, I don't think we should do conveniences just for fun.
The other option was, I don't remember if this is just me making things up, but Cron maybe had a flag in the Docker file syntax where you could specify the user, or was that for copy? I'm forgetting, but like one of those things you could specify -- user along with the argument and just change it for that step. I don't remember if that was for run or just for copy.
Probably copy.
I don't remember either.
I think it's copy.
I think if we decided to introduce functionality where we're going to switch the user back and forth, doesn't require the user to explicitly put things in the Docker file, at least it shouldn't be the default, and it should be something that as the extension author, you have to explicitly put, root at dash and dash back equal true somewhere to really, know that they're enabling this behavior. But I think I'd even lean towards not providing that as an option and really making them do it explicitly.
So the only reason I think that we might want to provide something like that is because the order of extensions isn't guaranteed. Because there's no way to specify an order for extensions. There's no way to know which extension would have run last. So if an extension ran that flipped it away from something you wanted it to be, there's no way within an extension to ever control what user ID it ends up as, because you can't control the order that extensions execute in, and therefore could be additional extensions running that may leave you in a different state. So we're the only people who actually have the control of knowing what the last thing that runs could be.
It's interesting. I was thinking about the things that would go into the build args are literally right before this individual Docker file runs. What is the user ID and what is the group ID? And then that's the thing that you can switch back to.
Yeah,
you
no,
know,
I'm fine with that. That would be a daisy chain connection of user IDs that would flow through the extensions at execution time, regardless of the order of execution of the extensions. Everybody has the opportunity to potentially contribute, and if they can change it on the way out as well, I don't know. It gets messed up there, but we're going to end up talking in circles, and we're hitting near the hour, so I'm going to go quiet now.
I think that doesn't give you what you want, though, right? You want to know what it is the very beginning somewhere else, maybe. Yeah, interesting. We should
We should
put more thought into it. Sorry, go ahead.
we should also limit the syntax of Dockerfile stuff we're supporting. Like we are not going to support every instruction out there. I think we should be very explicit in that RFC or spec on which instructions we do support. I don't think we can support anything and everything. Like, I certainly don't want us to support on build or volumes or stuff like that. So let's limit the scope to what we support as well. Like it should not be implementation dependent. Like Kaneko supports this, so that's why we support that. We should list out what we support.
The portability is an interesting question there. Like I would disagree on the grounds that, again, it's like an escape hatch, right? But if your app isn't portable between the Kaneko implementation and the BuildKit implementation, right, that's probably a problem.
Yeah, for example, BuildKit will probably allow you to change the front end or like allow build time mounts for secrets, which Kaneko wants. So we should be explicit about what we support.
All right, we are out of